Now that we've gotten through the basics of JavaScript, we're going to begin focusing on how we can use JavaScript to work through and manipulate data that we get from various sources, whether it be from a file on the hard drive, or it be data that we're pulling back through a web request to a web service, web API, or a website. Now, that data can come back to us from those different places in different formats. It could be plain text, it could be binary, it could be JSON, and it could be XML, or it could be some older data format that we're not used to. It could be SAML or something like that. And what we're going to do right now is we're going to focus on how, once we have data, we use that data inside of our applications. And that brings us back to a concept that we learned a little earlier in these video series, and that is the idea or the concept of objects inside of JavaScript. So in this video, we're going to do a little refresher on JavaScript objects, how we use them, how they're composed, how they're structured, and how we can modify them. And once we've gone through that refresher, then we're going to jump into what we call JSON, which is probably the most utilized format for passing data across the internet today. Although we do have a lot of different formats, JSON is probably the most widely used at this point in time. In the early 2000s, it wasn't JSON that was used, it was primarily XML that we used. And XML was highly complex, a very versatile but very verbose format for data. And JSON really just simplifies everything. And because JSON is already in the format of JSON objects, it's just logical that we begin to use those as our data structures inside of JavaScript in the front end. But we'll get to JSON in the next video. So let's get to objects. In JavaScript, when we learned about objects in a previous lesson, it was a pretty brief overview of objects, and we're going to dive a little bit deeper. When we learned about objects, we learned that we have a literal syntax, and we call it a object literal syntax. And that's where we are, and it sounds corny, but where we are literally creating an object in our programming script right there in our script as the script executes. An example of this would be let person equal, and then we use the curly braces just like we do on the body of a function or any other kind of block element in JavaScript. But instead of creating a function, we're creating what is probably most likely or best compared to a hash or a dictionary in other terms, which is really just a key value pair or a data structure that holds keys that have values assigned to them. And in JavaScript, our objects are simply key value pairs. So a person, they're going to have a first name, and then we assign a value to it, just like that. And then they're going to have a last name. And of course, we get to decide what the properties are on our value. And of course, our properties right here, it's the name that describes the value that we are holding that makes this particular object unique. Now, one thing we need to look at here is that I may be describing the category of objects called a person, but the reality is I have a single object here with unique data, which means that this isn't a category, this is an actual instance of an object that we are calling a person, and this happens to be an object that reflects my personal values, so it makes it unique to me. So instead of calling it person, we're just going to call it person Tim, so that we know that this is a person object and that we are dealing with Tim. So a specific instance of person called Tim. Now, because we're using the object literal syntax right here, we haven't really gotten into classes which were added in ES 2016. And so we are literally creating the object as we execute our program, whereas now in newer versions of JavaScript, we do have the ability to use classes and be a little bit more object-oriented, kind of like C# or Java or Ruby or any other object-oriented programming language. Now remember, JavaScript is a functional programming language, and that's why it's a little different. So if you already know Java or C# or any of those object-oriented programming languages, up until now, JavaScript has seemed a little basic and also more focused on functions than it is on objects or classes. And that's the primary reason why. So let's stick with our object literal syntax for now, and let's talk about how we can use objects in JavaScript for data and how we can modify and manipulate that data as we progress through our script. So right here we got person Tim, and then Clark would be the last name, and then just like any other object, we can describe other properties that an object has that makes it unique. So we can do our hair color, and we'll go ahead and let's say brown, and then let's say eye color, and they are blue. All right, so we've got some data that makes this a unique instance of the person object, and it is specific to Tim. Now, unlike an object-oriented programming language where we would have a class template that defines this, and then we would actually instantiate an actual implementation of that class, here we're just creating that data and that structure in line as we go. In other words, we are literally creating the object as the script executes. So keep that in mind. All right, so once we have our object, let's jump back really quick to how I called this a hash map or a dictionary or a key value pair data structure. And this is where we actually see that. When we think about a dictionary, if you think about a dictionary as in a standard dictionary book that holds English words and their definitions, it's very similar. If you think of the curly braces as the book, and then each of these would be an entry in that book where we have first name and then the definition. So that's kind of where we get the term dictionary from. We talk about a hash map, that's specific to computer science, and a hash map is really just a data structure that has a key, which is descriptive, and represents a specific value, which is unique to the hash map. And really in JavaScript objects are really just hash maps. So here we've got our hash map for Tim with all its associated properties and values that make it unique. Once we have that object, down inside of our script, we actually have the ability to access the properties of the object and receive or have access to the values that are held within those properties. And if we think about this a little bit more, maybe we can get a little bit more clear. Inside of this object, we really have a variable called first name that points to a string in memory that's Tim. And this object itself actually references each of these variables as its properties, and each of these variables then references a particular value that's in memory somewhere. So just think of it as a collection of variables, just like we would if we were outside and we said let first name equal Tim. Oops, not time, but Tim. This is almost equivalent to this in that memory is allocated and a value is stored, but those memory spaces, instead of being referenced by a variable name right here at the root of our script, that variable is actually referenced by this object, which is referenced by this, and therefore we can get to the variable that holds the string Tim by simply using dot notation. And we learned that when we learned about objects, and we've been using it a lot as we've been learning JavaScript. But really, dot notation is a way to tell JavaScript that as we are working with an object or a function, we want to be able to get to one of its properties. And so when you say person Tim dot, what you're really saying is, well, let's finish this expression and then we'll draw it out using our screen ink tool so we can see what happens. So if we have person Tim and then we say first name, and let's wrap this in a console.log. That way we can see what gets printed out. Let's go ahead and execute it really quick. And we see the value Tim right there. So let's go ahead and diagram out what is actually happening here. Let's go ahead and get ourselves a circle for our object. All right, so right here, we have this object, and this is how I like to think about it. There's, of course, more technical terms and descriptions for this, but we're going to say super high level, just so we can get the basic concepts down. Okay, so we've got this variable right here, which is person Tim, and it references this object definition right here, this literal object right here. Well, if we're going to think of it visually and in memory, we've got person Tim. It points to our object, and so this object, of course, is represented by this. This object, it then has references to these little, of course, containers that we've talked about, which are our variables. And we have these variables that we've got, and it has these variables inside of it. Actually, let's put them outside so we can see that better. So we've got first name, we've got last name, we've got hair color, and we've got eye color right here. Right, and maybe we should put the names here just so we know which one's what. First name, position that right there. We've got our last name, position it right there. We've got our hair color. Put it on top of there. All right, so hopefully this isn't too tedious, but what we're doing here is I want to show graphically how this all works at a high level. Keep in mind, this is a high level. It's a lot more complex than this, but at a high level, this is what happens. So we have our object right here, which is referenced by this variable name. Then we've got the properties of this object, which are variables themselves, or little buckets to hold data, right? And this object actually references each one of these variables that we've got. And then these variables, of course, they then reference somewhere in memory where we actually have a value. And the values we've got going on here, of course, are these strings right here. So somewhere in memory, we would have the string Tim out here in memory somewhere. And then we would have Clark floating out in memory on the heap somewhere. And we've got the hair color of brown floating out in memory. And then we've got our eye color of blue, and it's sitting out there in memory somewhere. We'll think of this empty space over here somewhere out on the heap. These, of course, sit on the stack, and then they point to the values that are stored out there, like this. So if we visualize this chain right here of variables that are sitting in memory and sitting on the stack, what we have here is we've got the variable person name. It points to this object definition sitting in memory. And then that object definition then has references to each of these variables that are actually, of course, references to memory addresses, which point to where these values are sitting in the heap in memory. All right? Now, if we look at this, what really happens here when we call person Tim dot first name, what is actually happening there is when we call person Tim, we're calling this variable, right? This variable then references, just like this up here, because it's the same variable, it references the object. And so at the end of this call, because this is really a call to this variable, here we're defining the variable and we're initializing the variable with the object. So this is all setting up everything in memory. When we begin to execute our program and we make a call to person Tim without the let in front of it, we are actually making a call, and JavaScript sees this and it says, okay, awesome. This person Tim references something in memory, so behind it, of course, we've got a memory address, and it points to where this object is at. Well, we don't have the addresses to each of these variables inside of our program right here. We don't have access to them. We have to access them through the person object, because the person object is the one that actually contains the references to all these variables, which then have the location to these actual values sitting in memory. So we actually access any of the references that this object has inside of it by using the dot notation. So let's get back to this. Person Tim references this object. When this call is made, what is returned back in place of this is this object in memory, the reference to it. So when we call dot, dot is actually being called on this object. And dot is a special operator in JavaScript which says, hey, look inside of whatever is returned by this call. Let's look inside of it and let's try to find whatever's asked for after it. So person Tim refers to the object. Dot says, let's get ready to look inside of that object for something. And then we follow it directly by the property that we're looking for. This, of course, is the human readable name that we reference the memory location of a value that corresponds to that particular property. So here we're saying first name, and so we're not accessing first name from right here. What we're really doing is this dot notation got us back this object, and it says, hey, look inside this object and find us the property first name. So it goes right here and it says, oh, look, we've got first name right there. Locates that variable which has a reference to the memory space that holds this value. So this ends up being an actual call on a property within this object. And when we make that call, what is actually returned to us at the end of this call, right here at this very end, is the actual value that was stored in memory. So that's why when we get this printed out by log, we get the value Tim printed to the screen instead of the memory addresses to all of these locations in memory. We get the extra value, the actual value. And that is because we are following these memory locations which are stored by human readable variable names. And we are looking inside of the object or function that we're working with. Here it's an object. And then inside of that object, we're looking for a variable name that holds a reference to an actual value stored in memory. That value gets returned. That value is what console.log, this method, actually prints out to our console. Hopefully, how objects work and how the dot notation works is like crystal clear now for you. So let's talk about how we can also access property names on an object. We can also access them not just through the dot notation, but we can actually access them just like we do inside of an array. Arrays we index using the square brackets, and then we use an index like 0, something like that. So if we do and we run that, we'll see that 0 is undefined. So let's try 1 just for the fun of it. It's undefined. That's because unlike an array, you can't use number indexes. Arrays, we know, are indexed by numbers because instead of property names that are human readable, it's something like this, right? And so with that, we can actually index an array like that, and we'll get the value back. But now we've got first name is undefined, but we can get to index 0. So let's undo those changes really quick. And with the understanding that we can still use the bracket, the square bracket notation to index an object, what we have to provide is instead of a numerical index, we just need to provide the property name. So we already pulled out first name. So let's go ahead and pull out last name as our property name. Run that. We get an error. And that is because we used last name as though it's a variable. Right here we've got it as a variable. We've got first name, we're using it as a variable name, but we're allowed to do that because of the dot notation and because of how the dot notation works. When we are dealing with property names and we are using the square bracket to index our objects, we need to wrap it inside of a string. And it will look at all of the property names, convert them to strings, and do a comparison against the string we passed in. So now when we enter it, we get Tim and we get Clark. So we've got this new way to index properties of an object. We can do it with dot notation, so long as we know the name of the property. We can also use the square brackets and index it just like an array would, but using a string. This is kind of the normal way of indexing a hash map in other languages. And so we're just kind of retaining that style right here. So we've got two different ways to get to the property of an object. And this one works identical to what we had before. If we open this up, it works identical to this. We have, oh, it looks like it doesn't give us our full screen right here, but we still do the same thing. It calls person, goes to this object, and then the square brackets also does the same thing that the dot notation does. It says, hey, go in and look inside that object and let's find a property on that object that has the same string name as last name as a string. It takes each property name, converts it to its string representation, and then does an equality operation on it to see if we have a property in there that has the same string representation as this. Just so happens we do. So we end up with last name, and we get the output Clark. All right, so we've learned how to access properties within an object in two different ways, using the dot notation and the bracket notation like we do on arrays or hash maps. Now let's talk about how do we get rid of a property in an object if we no longer need it? How do we delete a property? And really, we can delete properties on an object using a special operator that JavaScript provides us. It is a global operator that we can use on objects and functions to delete properties off of them. And it's as simple as using that particular operator, and it's really, really nice because all we do is really use the word delete. So delete is our key word for deleting a property off of an object, and then I can say person Tim, and then I can specify using dot notation the property that I want removed from that object. So let's go ahead, and I don't want my eye color saved in this object, so let's go ahead and do that. Let's add a little console.log right here that actually shows that our eye color is part of the object before we do the delete. And then let's go ahead and add another one after it that shows the delete happening on our object. And that is no longer a part of the object once the delete operation has happened. So here we got Tim Clark Blue, and that of course corresponds to line 10, 11, and 12. We perform a delete on the person Tim object. We specify we want to delete the eye color property. When we do a console.log on person Tim, we see that eye color is now undefined. And then if we just go ahead and print out the entire object, and then we expand it, we'll see right here, first name, last name, hair color, and eye color is no longer a part of that object. Let's go ahead and do that right before the delete, and we'll see that over here, eye color is still a part of that object. So here, we've seen how we can access properties. We can do it in two different ways. We can also delete a property. And then just to make sure we still remember from our objects lesson, we can also change the values of any of our properties using the dot notation and the square bracket notation like we did before. And let's do that really quick just so we can see the difference. I'm going to go ahead and we're going to put some space right here. So we got eye color right there. Oops, I didn't mean to put a space by the delete. We got our eye color right here. Let's go ahead and change the eye color and then print it out again. So we'll do person Tim.eye color, and I am going to set it to purple. So now I've got an eye color of purple. Maybe I put in some contacts for Halloween. So go ahead and run that. We'll see I've got Tim, Clark, blue. Oops, we didn't reprint out our eye color so that we can see it in our console. We got Tim Clark, eye color was blue, now it's purple. Now we deleted it, and now it's gone. We can also do it using the bracket notation as well. So let's go ahead and let's copy these two lines. Let's repeat them again. And this time, instead of using dot notation to change the eye color, let's go ahead and use the square bracket notation like we would on an array or a hash. And then let's go ahead and change it to red. And now we've got those printing out. Right, we got Tim, Clark, blue, purple, red. It's still part of our object. We delete it. It's no longer part of our object. Okay. Now, the last thing we need to remember about JavaScript objects before we move on. I know this has been a long video, but let's finish this last item really quick. And that is dynamically adding properties to an already existed or already instantiated object. So here we've got our person Tim. We can see by our last output of the object that we have first name, last name, and hair color. What if, as we're going through our program, we ask the users some questions, they post back a web form, and we get some additional information that we need to tie to that person in this person object? Well, we can simply do that using the two notations that we were already used to. We can use our person Tim dot, and this time we just dynamically create whatever new property we want. So let's go ahead and add height to our object, and then we're going to go ahead and do that in the form of a string, and we're going to say 6 foot. And then we can also add another, but we can also use our square bracket notation, and we're going to add weight, and let's go ahead and put 190 pounds. And then let's print our object out again just so we can see if those properties have actually been added dynamically to our object. So let's go ahead and run it. Here's our object after we did the delete of eye color. You can see it stops at first name, last name, hair color. And now, if we look closely, let's see, can I make this bigger? There we go. We've got ourselves in this object after we've added to it. We've got height now added and we've got weight added. And we did that dynamically simply by using the dot notation and the square bracket notation by adding new properties that did not exist on our object. That's one of the cool things about JavaScript and the fact that it's a dynamic language, is that we do not have to have everything on an object when we first define it. We can add new properties to our objects even after the object has been created. And we can do that dynamically just by specifying the new property and assigning a value to it when we use the dot notation or the square bracket notation on that pre-existing object. So really important that you understand all of this, how we manipulate objects. We've gone through adding properties, updating properties, deleting properties, and of course the basics of objects and what they really are, hash maps or key value pairs that are all referenced in memory by this object that is referenced by a variable, and then inside of it, it has references to all of the property variables that then hold references to all the values in memory. And of course, this is high level. You can get a whole lot more specific on how all this works, but this is a good way to remember it at a high level.